Hello everyone. So in this video we'll talk about percentiles and median. I'm going to start out with the definition of the pth percentile of a set of numbers, which we'll call a data set. Um, and then we'll go through a process of how we find that particular quantity. So uh, first off, let me just say, write down what I just said. So we'll refer to a set of numbers, which, as last time, we wrote in terms of D1, D2, etc., up to D sub n as our data set. This is our data set. Okay, and so given a data set, we'd like to find a number that we'll call the pth percentile. Okay, so what is that? So here's the definition, and then, as I said, we'll go through a method to compute this number, and then we'll talk about some examples. All right, so the pth percentile of a data set is a number which we'll denote by x sub p, such that p% of the data is smaller than this number, is smaller than x sub p, and 100 minus p, so the remaining portion, 100 minus p percent, is larger than or greater than to, larger than or great, or equal, I should say, or equal to x sub p. So this is the notion, this is the definition, and if that just glazed right over you and didn't make any sense, well, let's give a method to compute it, and then we'll try to interpret it again, looking at some examples. All right, so what is the method? So how do you find, this is the sort of fun, or like the part that you may want to pay attention to, is how do you find a percentile given some data? So the way you do this is a step-by-step process. So the first step, or maybe the book calls it the 0th step, is to organize your data so that it's increasing. So that you have an increasing. And here, I guess we'll assume for the moment that that we don't have the same number each time. So maybe everything comes with frequency 1 just for fun here. D1, D2, D3, and so on, up to D sub n. If you have a lot of equality, it's maybe this definition doesn't work so well all the time, because you may not have such a number that splits your data set up in an equal way. So, but let's assume that we have sort of distinct data points. All right, so that's easy enough. Step 1 is we're going to find something called the locator. So it's called locator, and it's written L, and it's just a simple equation. We take our number P, we divide by 100, and then we multiply the number of data points N in our data set. That gives us our so-called locator. Okay. And then step 2 is the final step of our process. we have to discern whether or not L is a whole number or not. So if L, so one option is if L is a whole number, meaning it's a number like a counting number, 1, 2, 3, 4, then we define x sub p to equal, we take the Lth point in our data set and the L plus first point in our data set, and we take their average. We divide by 2. Okay, that's our pth percentile. Most of the time, L will not be an integer, but sometimes it will. If not, if L is not a whole number, then let your locator L plus, sorry, let L plus be L rounded up. So we round up. And then take x sub p to equal d sub L plus. All right, so this is it may look a little funky here, but this is the way we can find the pth percentile. Okay, so if this process looks a little daunting, let's give an example and see if we can't go ahead and compute. So I'll go down, and again, this is in the book, so please reference the book if you can. I'll make this screen so everything's in front of us, and we'll write down an example. All right. So I'm going to write down some numbers. These are numbers 9, 5, 2, 1, 11, 7, 15, 12, 8, and 10. Okay, so these are all distinct numbers. I'm not repeating a number more than once. And I'm going to I'm going to find the piece. So let's find the 30th percentile, the 45th percentile, and the 50th percentile. So they don't have to be, well, these should give us different numbers, at least typically. All right, let's take a look. So we need to perform our step 0 in all of the cases. It's the same step. We need to organize the data so that it's increasing. Okay, so let's go ahead and do that. I have 1, 2. I'm going to cross these out as I go so I don't repeat. 5, 7, and 8. Okay, let's see here. 5, 7, 8. Next one is 9, 10, and 11. 12, and then 15. Okay, I think I've got 9, 10, 11, 12, 15. Okay, great. I've got all of my numbers, and now they're arranged in increasing order. Wonderful. Next, I need to find my locator, but the locator now depends on which problem I'm solving, 30, 45, or 50th percentile. So let's do the 30th percentile first. And we'll perform step 1. So we need to find L here, and L is going to equal 30 over 100 times n, which is, what is n? Well, to find n, we have to count how many numbers we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers, n is 10. So equals 30 over 100 times 10, and that is equal to 3. So L in this case is 3. And now I've completed step 1. I look at step 2. We have two possible cases, if L is a whole number or if L is not. In this case, L is a whole number, 3 is a whole number, so we have to use this formula here. So I'll write that down. In this case, x sub 30, this is my step 2, x sub 30 is equal to d sub 3 plus d sub 4 over 2, average of them. What is d sub 3? Well, this is d1, d2, d3, d4, d5. I'll write a few more, d6. Okay, that's all I'm going to write. So d3 is 5, and d4 is 7. So I have 5 plus 7 over 2, which is 12 over 2, which is 6. So my answer here is 6. That was the 30th percentile case. And now we need to do the 45th percentile case. Let's take a look. Again, we go ahead and we compute the locator. Step 1, L is equal to 45 over 100 times 10, which is equal to 4.5. So in this case, our locator is not an integer. It is not a whole number. So when we look at step 2, we need to consider L plus by rounding up. L plus is equal to 5. And so in this case, x, the 45th percentile, is just going to be d5. I go ahead and look up. d5 is 8. So I'm in good shape. No computation necessary. There we go. Okay. The last example is the 50th percentile. Okay, so we go ahead. Let's ask about the 50th percentile. Again, we're going to do our step 1. And we'll see, okay, L is equal to 50 over 100 times 10, which equals 5, which is a whole number. And so step 2 tells us that since it's a whole number, the 50th percentile is just d sub 5 plus d sub 6 over 2. I look up again. d5 is 8, d6 is 9. I have 8 plus 9 over 2, which is 17 halves, or if you want, 8.5. So not hard, but once you get the hang of it, but it takes a second to get the hang of it, and it may not be a bad idea if you're already writing up sort of a note card for the last exam to go ahead and write down this algorithm, this step-by-step process of computing a percentile. Now, this last example, the 50th percentile, is one that's used so frequently because it indicates sort of that point at which, half the data is less than or less than that number, and then half the data is greater than or equal to that number. And this goes by another name. There's a special name for this one, and that is the median. So another word for the 50th percentile is the median. I should write that in red. It's a new term. And many people that are not that haven't taken 160 or a stats course confuse the mean or average with the median. Those are two different numbers typically, not always, but typically. Um, and the median, and they sort of mean different things. As we saw last time, the mean or average is sort of that center of mass. The median is sort of is that point at which half of everything is less than is less than that point, and half of everything is greater than or equal to that point. So they represent different quantities. Okay, so let's take a look. Now, this computation we just did uh, was one, this last computation here was one of computing the median for the data set. You'll notice that in this computation, we found that L was a whole number. It was 5, but that actually depended on some feature of our data set, and that was that our data set had n equal to 10. And in particular, when you have an even data set, um, you will get this situation occurring again. So let me just make that clear. So if the data set has n even, then the median is just going to equal d of n over 2 plus d of n over 2 plus 1 over 2. In other words, it's going to that locator will be a whole number. So here, because L will be a whole number. On the other hand, if it's odd, L will not be a whole number. So if n is odd, you just take the middle data point as your median. Then the median is simply d of n plus 1 over 2. So let's take a look at another example. Let's say we have a data set 1, 2, 3, and then we'll jump up to 10 and 11. Okay. Now this is one data set, and then I'll do the same one, but I'll tack on another. Let's tack on another one. We'll say 100. Okay. So what are the medians in these two cases? So in the first case, we have five. In the first case, we have 5 data points, right? 5 numbers, 1, 2, 3, 10, 11. So 5 is odd. So we are in this situation. N is odd. 5 is odd here. So this is n equals 5. And so what is this median? It's just going to be the middle data point, right? These are already organized in increasing order. The middle is right here. It's going to be exactly d sub 3, right? Or if you want to use the formula, 5 plus 1 over 2, that's 3. That's equal to d sub 3, which is equal to 3 in this case. Now here on this right-hand side, n is 6. I've tacked on this other point, 100. So we are in this case where n is even. And now we have to take an average. We don't have that singular middle data point, right? This is the first, second, third, fourth, fifth, and sixth. So these two sort of are in the middle. And we would like, instead of taking one of these two, which wouldn't give us the correct percentile, we'll take the average. So we'll take something in between this. So here, x sub 50 is going to equal um, d sub 3 plus d sub 4 over 2, d sub 3 being 3 plus 10 over 2, and this is going to equal 13 halves or 6.5. Okay, great. Now, I want to make one final point here. Let me just seize on this data set here to make this point. So if we compute the average, right, of these numbers, I'll get something that looks like 1, 2, 3, and then, okay, 4, 4, 10, and 11. So this is just a rough sketch, but okay. These are my data points, right? And you can see if you were just looking at this, if I say, okay, my median is here, this is the median. And on the other hand, what is my average? The average is I add all the numbers, 1 plus 2 plus 3 plus 10 plus 11, and I divide by my n, which in this case is still 5. Okay, so I don't know what this is. It's too complicated, but let's calculate. 1 plus 2 is 3, plus 3 is 6, plus 10 is 16, plus 11 is 27 fifths. So this is like 5.4 if you want. 5 and 2 fifths is 5.4. So 5.4 lives sort of around, I don't know, around here, let's say. This is the mean. And you can see that these are definitely two different numbers. The mean, if I were to make a teeter-totter, will be that point where everything is balanced. If at each of those 1, 2, 3, 10, and 11, we put a single mass of weight, say a pound. This is where you would get balance in that teeter-totter. The median, you would definitely not get balance. You know, the right-hand side would kind of fall down. But the median is sort of the number at which everything, you know, less than or equal to it is 50%, or everything greater than or equal to 50% of the data is equal or greater than the median. So this is this is something to illustrate that oftentimes your mean and your median are extremely different, and so they can be wildly different. But they both give you some kind of notion of the center of the data or the middle of the data, but they do have a different meaning. Okay,